In example 8c, we're trying to find the exact value of the cotangent of theta over 2, given that the tangent of theta is equal to negative square root of 5 over 2, with theta being between 90 degrees and 180 degrees. All right, let's figure this out. First of all, look at what we're trying to compute. We're trying to compute the cotangent of theta over 2. Do not automatically jump the gun and say all I need to do is 1 over the tangent. That does not work here. Why? Because these are two different angles. Okay, this is theta over 2. This is theta. Okay, if you do 1 over the tangent of theta, that is the cotangent of theta, not the cotangent of theta over 2. Okay, absolutely have to keep track of what angle you're dealing with. Okay. All right, so we're going to have to do this in a different way here. Okay, let's go to our half angle formulas. Okay, here's another issue. Okay, when you look at this, there isn't a formula for cotangent. Yay! So how in the world are we going to handle that? Well, let's go back, and what I can do is say that the cotangent of theta over 2 is equal to 1 over the tangent of theta over 2. Okay, that's how we're going to have to handle this. And then we know there's a half angle formula for tangent. And so that's what we're going to have to work with. And then once we have the value of tangent of theta over 2, we'll have to do a 1 over it. And then that's how we're going to get the cotangent value. Okay. All right. So I am going to write down a half angle formula for tangent. Okay. So tangent of a over 2 is equal to what? Well, we have to go pick from among the three different formulas. So if we come over here, let's see, we're looking at 16, 17, and 18. Again, we need to use either 17 or 18 because those two are easier to work with. It doesn't matter. I'll just pick one. I'm going to go with 18. I don't think we've used that one yet. Okay, so sine A over 1 plus the cosine of A. Okay, so this is equal to sine of A over 1 plus the cosine of A. Okay, going this route, you don't have to deal with the square root, which is nice. You also don't have to pick the quadrant. Okay, so it's a win-win. Okay, so if we do this, okay, we are trying to do tangent of theta over 2. So for our purposes, A and theta are going to be equivalent. Okay, so we're going to be looking at the tangent of theta over 2. When we plug into this, this is going to be the sine of theta over 1 plus the cosine of theta. Okay, so what we need in order to be able to plug into this formula, we need the sine of theta and we need the cosine of theta. Okay, look at what we're given. We're given the tangent of theta. So from that information, we'll have to come up with the sine and the cosine. Okay, so let's go ahead and draw a right triangle. Okay, this information, keep in mind, is about theta, and theta is in quadrant 2. It's between 90 degrees and 180 degrees. So we'll go ahead and draw a right triangle in the second quadrant here. All right, so here we go. So here comes my terminal side. And then I'm just going to draw down to make a right angle. All right, so here's my right angle. This is going to be theta. It is not theta over 2. Okay, so here's theta. We know the tangent of theta, which is the opposite. Let me move this over. The opposite over the adjacent. Okay, so we're going to have to equate that. So tangent of theta is negative square root of 5 over 2. This is the opposite over the adjacent. Okay, so when we look at our drawing, if we go straight across from the right angle, this is the hypotenuse. If we draw straight across from theta, this is the opposite side. The other side is adjacent. Adjacent is along the negative x-axis, so the negative needs to go with the adjacent side. So it's the 2 that needs to be negative, and the square root of 5 that needs to be positive. Okay, if you look at the opposite side, it is parallel to the positive y-axis, and so the opposite side needs to be positive. Okay, so if we label this thing, the opposite side is the positive square root of 5, the adjacent side is negative 2, and we need to get the hypotenuse. Okay, so if we do c squared here, that's equal to a squared plus b squared. Okay, so we're going to get we're calculating c squared, so we're going to get negative 2 squared plus the square root of 5 squared. That's 4 plus 5, which is 9. And lucky for us, that means the square root of c squared, or sorry, the square root here, if we take the square root of both sides, we're going to get that c is 3. We're solving for the hypotenuse. It has to be positive, so it's going to look like this if you label all the sides in your triangle. Okay, so we can go ahead and write down from this that the cosine of theta, which is the adjacent over the hypotenuse. Okay, I got to make sure that this is clear. This is the cosine of theta, not theta over 2. Cosine of theta is going to be the adjacent over the hypotenuse. This is going to be negative 2 over 3. And then if we do the sine of theta, this is the opposite over the hypotenuse. This is going to be square root of 5 over 3. These are the values we plug in, okay, to compute the tangent of theta over 2. Okay, so this is going to be the sine. The sine is the square root of 5 over 3 over 1 plus the cosine, so 1 plus a negative 2/3. Okay, we're going to have to simplify this stuff. So let's see here. We're going to get the square root of 5 over 3. The bottom is going to be 1 minus 2/3. Okay, so this is going to be the square root of 5 over 3. 1 minus 2/3 is 1/3. Okay, so luckily this is not too bad. Divide the fractions. This is going to be the square root of 5 over 3. Change the multiplication, flip the bottom. Okay, the 3's cancel. Okay, so we're going to get that this whole thing turns into the square root of 5. Okay, we're not done. This is the tangent of theta over 2. Okay, we just said that value is the square root of 5. Okay, what did we want to calculate? We're trying to find the cotangent of theta over 2. Okay, so to do the cotangent of theta over 2, this is 1 over the tangent of theta over 2. Okay, so we have to do 1 over the square root of 5. Okay, rationalize the denominator. And so our final answer is the square root of 5 over 5. And we are done with that one.